So what we'll do, we'll start straight line today. And sequential series, if you have doubt, it's again see mostly the chapter that we studied was permutation and combination. That you have to think a little bit. Okay, and I think we have done that efficiently. You can solve even JEE mains level problem. I'm sure. Not advanced, but mains level definitely you'll be able to solve if you'll just pay a little bit of attention in that. But anyway, I suppose, what is this question paper? Certificate paper language. What's that paper, right? I'll use this. Too many options. Bhaskar? Bhaskar, are you there? No, actually, I wanted to use my tablet. I have a lot of problems. I'll exit from here, okay? Guys, I'll be joining. It just not end. I'll just leave. Sign some material. We were able to hear. What's the name of this chapter? Straight lines. Okay, so straight line will be studied. Let me change. Just a minute, just a minute. Use this page. Will that be okay with you guys? Huh? Yes or no? Straight line. See, before we start straight line, we'll revise few formulas. You have a book? Not okay. Okay, I'll use this. Okay. So write down distance formula. Hopefully everyone knows that. Right? You remember what a distance formula is? Yeah. What is x2 and what is x1? Yeah. Okay. So that means suppose if you are given a coordinate system, coordinates, right, of 2 points. Let's say this is point A and some point B. Okay. Right. So how do you measure the distance between these 2 points? From this point to this point, how you will measure the distance? So let's say the coordinate of point A is x1, y1, and this is x2, y2. So according to distance formula, AB is equal to what? We'll just use the Pythagoras theorem. Okay, I'll just tell you. I'm not going to go into the proofs and all because we need to study straight lines. So this AB is same. AB square is equal to, let's say this point is C, AC square plus BC square. That's what we are going to use, the Pythagoras theorem. And we can write AB is equal to x1 minus x2 whole square plus y1 minus y2 whole square. You can also write square root of x2 minus x1 whole square plus y2 minus y1 whole square. Because when it is squared, when you square this function, it is already positive. Okay, so no need to worry about this. All right. So this is your distance formula. All right. Yes. So find the distance between. Okay. So let's solve a problem. Find the relation that must exist between x and y so that. Okay. So 2 points are given. 6 minus 1 and b 2 3. Find AB. Just find AB. AB is how much? So 4 square minus 4, 16, 16 plus 16, right? 32. So that is 4 root 2, isn't it? 32 is 4 root 2. So 4 root 2 unit. Okay, because it's a distance, so you must write the unit. So it's 4 root 2 unit. Now I'll extend the problem. Okay, suppose there is a point P. Okay, x, y. There is a point P, x, y. Now you need to find a relation between this point such that AP is equal to BP. So find the relation. Find the relation. How you will do that? Is given that means same. Suppose you are given a coordinate system y, x, and some line AB is given. Okay, and P is here at the midpoint x, y. So what equation? Relation means you have to find the equation. Okay, so you just do AP is equal to BP. Find AP is equal to BP. That will be equal to x minus 6 whole square plus y minus 1, that is y plus 1 square will be equal to square root of x minus 2 whole square plus y minus 3 whole square. Fine. So you will define a relation. So this square root will get cancelled. You don't need to write square root again, right? So this will become just expanded. You will get the answer. X square plus 36 minus 12x plus y square plus 1 plus 2y should be equal to x square 4 plus 4 minus 4x plus y square. What else? Plus 9 minus 6y, right? So x square will get cancelled. Y square you can cancel. So this will become x minus y is equal to 3. So that is the relation we need to find out. Okay. Got it? I'm not going to waste much time in this. Okay. So using this, we can prove isosceles triangle. We can prove equilateral triangles using the distance formula. We can do these things. Okay. Write down next. Write down section formula. Or wait. Before that, area of triangle analysis. Right? Area of triangle. Area of a triangle. Is it there in your CBSE? I'm in NCERT. You know why it is not there? Because it is common sense. I mean, you must have studied that in geometry before. So that's why. See, here we are studying the combination of geometry and algebra, right? So suppose again, any triangle you make, any triangle, right? Any triangle. Let's say this is the triangle you have. Okay, this is the triangle you have. Now you need to find the area of this triangle. That means you need to find this portion. How you will find? See, one method is using integration, right? But we haven't studied calculus. So let's forget integration. First understand, let's say this is A, some point A, x1, y1, okay, the coordinate, some point C, okay, let's point this point B, x2, y2, and this point C be x3, y3, okay. Now, if you extend these lines here, let's say if you extend these, right? Now let's name them. So let's say this is L, this is N, this is M. How you will find the area of this triangle? How you will find this? You want the proof. I'm not directly giving you the result. The distance formula proof you already have. That's why I didn't give it to you. Okay, area of triangle. How you will find it? Any idea about it? See, what you can do, you know how to find areas from such. I'm sorry, my mistake. So what you can do, area of triangle, write down. See, for area, I'll be writing like this. Okay, area. Okay, triangle, I'll just draw that. This is the symbol of triangle, by the way, or I'll just write this, area of triangle. Okay, so area of this triangle, area of triangle ABC can be equal to area of triangle or trapezium, sorry, trapezium, area of trapezium ALNC plus area of trapezium CNMB minus area of trapezium ALMB. Can you see this? Just see, observe if you are able to get it. ALNC, I'll just highlight ALNC, this trapezium. First, we are adding this trapezium. Okay, so this trapezium plus trapezium CNMB, CNMB. So this, you got the area of this and this. That means you got this area. Now what you are subtracting the area ALMB, this one, right? This is also a trapezium. So you have, see, why we have to subtract? Why can't we just write area of this plus area of this? Because it is easier to find using when it is on the coordinate on the x-axis. Okay, that's how. So we'll add this, and we'll subtract this part. So it will be easier for us to find it. Now do it. Can any one of you solve it? So how we can write? Area of trapezium is what? Half into sum of parallel side into height. So half into AL plus CN into LN is the area of triangle. This, where's the highlighter? This triangle we are finding. Sorry, this trapezium. So what? Sum of parallel sides. So which two sides are parallel? This side and this side is parallel. So we added these two sides and we multiplied it with the distance between them, the separation between them, right? And half of that. Similarly, you do for this triangle, this trapezium. Why I'm saying triangle? This one. This one. Yes, you are right. Say it. Half CN plus BM, yeah, MB into NM, correct, minus half into AL plus BM into LM. See, if anybody is having doubt, please tell me. Now this is this trapezium. Okay, so parallel sides are which one? This and this are parallel, and the separation between them is this. So that's what we have done, right? Now, because we have studied distance formula so far, we don't know anything. So from distance formula, we can find EL, CN, this, and this. We can find using distance formula. Okay. So, or what we can see now, if you have to find using this, sorry, this point and this point, then distance formula is little tough to write, right? When you are finding the distance between this point and this point, x, same value of y, right? Same value of y, that means it will be subtraction will be 0. So let's write down. That's why we are using this coordinates. Let's write down L, AL. AL will be what? Y1. Just check. You have drawn, no? AL is equal to Y1. BM is equal to how much? Y2. BM. CN is equal to how much? Y3. Right? Now LN is equal to ON minus OL. Check. LN, this one. Okay, sorry, I forgot to write. O will be this part, right? This is your O. Or you can O, sorry, O, L, O, wait. L, O, O, N minus. No, this will be plus, no, this is not minus. This will be plus, right? This will be plus. Sorry. So this will be plus, and I suppose this one is right? Okay. This is plus. Now write down what will be this. ON is how much? ON is x3 plus OL, right? OL is this one, isn't it? This one. That means it is x1, and x1 is actually negative, right? So, but we are using what we are using here. This x1 is negative, actually negative quantity. So can we write minus x1? X1 will be negative now. This is minus x1. No? If x is your see, x1 is negative, isn't it? Just check. Because x is in the side of coordinate system, that's why we are writing minus x1. You can write x, either x1 is equal to minus 4, let's say, or minus x1 is equal to 4. I'm choosing this one, okay, because it is easier to solve. Okay, both are the same thing. Understood? So I'm writing this part. See, anybody is having doubt, so please let me know. Okay, now write similarly NM. NM will be what? OM minus ON. OM minus ON. So that will be equal to x2 minus x3. Right? Similarly, LM will be equal to OM minus ON. LM. Right? Actually, this is plus. So again, it will be OM. Right? Plus. This will be plus. So this will become what? OM is what? OM is plus. So x2 minus x1. Got it? This point, these all you got x1, y1, x2, y2. So we got on this one. Now you just substitute. Let's say this is equation number 1 and this one is equation number 2. Substitute 2 in 1. 2 in 1. What will get? Area of triangle we will get, right? So area of triangle ABC will be equal to, I'm just directly writing the answer, half okay. So this is the area of triangle, and we will put this in modulus sign. Okay. Why? Because area is never negative. We are not considering area negative area. Okay. The magnitude, only we are writing the magnitude. Although area is a vector quantity. Okay. Area, let's write here, although area is a vector quantity. That means area can be negative. Okay, i.e. area can be negative, but we will be writing, we need only magnitude. Okay, so you can also write area A of triangle ABC modulus is equal to that part, whatever we have got. So equation number, which equation is this? Okay. So this is equation number 3. All right. So this is the area of triangle. Now one more shortcut method I'll tell you how to find area of a triangle. Now why in the first place I'm teaching you area of triangle? Okay, we will see that. After this, that topic is there. One more method to find area of triangle. Suppose you have any triangle, okay, and you know the coordinate of that triangle. In its shape of triangle you have, let's say A, B, C, x1, y1, x2, y2, x3, y3. This you are going to study in your 12th standard determinant, but actually it's very easy. You can just learn it. In fact, determinant you'll be using in vectors when you'll be solving vectors. They are cross products and all. So there you'll be using determinants, and it's very easy to understand. So area of triangle ABC is given by determinant of x1, y1, 1, x2, y2, 1, okay, x2, y2, 1, and x3, y3, 1. Okay. So this will give you the determinant. How do you find a determinant? Let's find it here also. So let's solve it. Okay. So this determinant, you keep x1, right? You multiply these two, isn't it? That's what we do. So y2 minus y3. That's what we do. Minus y1, right? Or you can just use this method. You can use this column method. Okay. So minus x2. Now, if you are choosing x2, this if you are choosing, that means this row and this column you won't be using. Only this multiplied with this minus this multiplied with this, right? So write down y1 minus y3 plus x3. What is the meaning? y1 minus y3. Okay. So this is your area of triangle. What? Where? y1 minus y2, no? Where you are saying? Minus x2, right? This one you are saying. See see again, you haven't studied determinant yet. You haven't studied yet. Okay. See, it's there are coefficients. Okay, so this is called C11. This is called C22. This is called C33. Okay, coefficient of this C12, C13, like that. It is named the elements of the or arrays of number. Okay, see this coefficient here. We multiply with these coefficients. So it is that C22. It comes out to be -1. That's right. Well, you'll be studying that in next. Just for now, just accept it that Sumit is saying so that it is correct. Okay, so that's how you can also find area of, sorry, half times. No? I forgot here, half times of this. Okay, this is half. Okay, half times of this. See, now you will also understand that area of triangle you found. No? See, when you do vector product A cross B, see, how do you write? You write exactly the same thing, right? So you write I cap, J cap, K cap. That means unit vector in all three directions, and A1, A2, A3, B1, B2, B3. That's what you do. That's same thing. And what is the magnitude of this? This magnitude is equal to a vector which is the area of parallelogram. Like if this is your A vector and this is your B vector, okay, and this is the angle, of course, from A to B, theta. So you will get a vector which is perpendicular to this vector. Okay, this is A cross B vector, whose magnitude will be equal to the area of this parallelogram. Okay, so this again is your B vector, this is your A vector. So this magnitude, this is your cross product A cross B. Okay, this magnitude is equal to this vector which you are getting. So this is the actual vector you are getting when you are doing A cross B. Okay, so that's the meaning. So same thing you are getting here also, area of triangle, right? That's how it is calculated. Now, why in the first place I asked you to calculate area of triangle? Why there is a formula? One thing is that maybe your determinants get cleared. Okay, the method of determinant, the cross product, we do the same thing. Okay, and that's why see area is always a vector quantity. Which direction? What is the direction of area? Do you know? I think I mentioned this in class one day. See, this board you can see, right? The light coming out of the board. It is in this direction, right? Coming out. So whenever if you're looking the board this side, the board is looking you from this side, right? So that is the direction of this area. Okay, normal to the surface. If you look from opposite side, that will be the vector will be that side. Like this is a phone, right? So this is the direction of this surface. This is the direction of this surface. Got it? That's why from that side you can say this is minus area, negative area. The magnitude remains same. Understood? Now, write down a statement. 3 points are collinear. 3 points are collinear if IFF. What do you mean by IFF? If and only if area of triangle formed by these points is what? 0. That means the determinant of these 3 points you will find is 0. That see, just understand, no? If suppose you have a straight line, okay, straight line like this, right? That means these 3 points can be collinear, A, B, C. How much area it will have? 0. Let's say there is another point D anywhere. If it is not collinear, so it will form some area, right? Not like that. It will form some area, even if it is closer or whatever it is, right? It will form some area. So you A, B, C are collinear, but A, D, C is not collinear. That it will form an area. So here, this determinant will not be equal to 0, but the determinant. So write down determinant of A, B, C is 0. But determinant of A, D, C is not equal to 0. Okay. See, that's the reason why I told you. How do you know whether 3 points are collinear or not? So this is one of the methods. Got it? Okay, I'm not going to give you problems based on this because this is not straight line we are studying. We are just revising some of the formulas. Okay, so and write down next section formula. Oof. Section formula. See, section formula means like 2 points. Suppose you have a straight line. Now you have a straight line, right? And this, let's say this is point P and point Q. You join these 2 points, you'll get a straight line, right? And there is a point in the middle somewhere, not in the middle, not at the bisector, at somewhere in between. So let's say this is point R. And this point R divides this point P and Q in a ratio m:n. Okay, write down m and n ratio. It divides. That means PR by QR is equal to m/n. Okay, so the section, now let's say the coordinate of P is x1, y1, and Q is x2, y2. And let's say R has got the coordinate x, y. All right. So how do you find x and y? So x will be equal to what? Do you know? M times x2 plus n times x1 divided by what? M plus n. Okay. Similarly, how do you find y? Same way. Y will be equal to m y2 plus n times of what? Y1 whole divided by m plus n. See, this is external division, right? We are dividing PQ. PQ is divided externally. Sorry, internally, no? Internally it is division. Sorry, not externally, internal division. Internal division. That means you are dividing this point PQ in the middle somewhere. Now suppose, then what is external division? External division. Now suppose you have point, what point we had? PQ, right? Or let's say some other point. Let's say PQ. Okay. Let's draw a straight line. PQ. This is our point PQ. PQ. Okay. Now, what do you mean by dividing externally? That means you will extend it. If this line is extended, it is dividing somewhere here. This is R. A point on this line. So the coordinate of P is x1, y1. This is x2, y2, and R is x, y. Okay. Now it is dividing this in m:n ratio. So m:n. Right? That means, see, just understand this here. PR by QR is m upon n. Here also, PR, you are getting it Murli or not? PR, yeah, n is from R to Q. See, if n is from P to Q, then it will be internal division, right? It is external division. So PR upon QR. That's what we are writing here also, no? PR upon QR, and that is equal to m upon n. Understand this thing. Okay. See, that's the meaning of external division. If you are saying this is n, if you want this to be n, then it will become internal division, which we don't want, which we already know, right? So in this case, how do you find x and y? Same method. Same method. So x will be equal to mx2 minus nx1 whole divided by m minus n, and y will be my2 minus ny1 upon m plus n. Please write down. See, this is external division. This is above one is internal division. Just try to understand the difference. It's a lot different. Okay. Write down fast. Again, I'm not going to give you any problems because again, this is just a revision. I'm just trying to short down all the formulas. That's it. Okay, what do you mean by centroid of a triangle? Centroid and incenter. There are two terms, right? Centroid. Centroid of a triangle. What do you mean by centroid of a triangle, huh, Murli? So if this is that means you will do bisection of sides, right? You will divide the side into, let's say this, you say divide the side here. So this is the midpoint of this side, this is the midpoint of this side, this is the midpoint of this side. And you join it to opposite edge. Not edge, sorry, opposite chord. Just hello. Yeah, I'm working. Can you call after like half an hour? Please call me after half an hour, okay? 7:30, I'll be free. Thanks. Okay, so this is A, B, C. Okay. Now same x1, y1, x1, y1, x3, y3, x2, y2. See, we can name any point, any coordinate, it doesn't matter. Okay. How do you find the coordinate of this point? Let's say centroid of triangle. No? So let's name it G. X, Y. How do you find X and Y? So X will be equal to X1 plus X2 plus X3 upon 3. And Y is equal to Y1, right on. See, this you guys have already learned. I'm not going to give you the proofs. If you want the proof, go and revise your 10th standard book. It is there. 10th standard or 9th standard. So this is called centroid. And there is another term, incenter. Incenter, right? Incenter of a triangle. Okay. Incenter. Let me try it again. So incenter just means, see here we are dividing the sides into equal parts, right? Like this is equal to this. This is equal to this. This is equal to this, right? Here what we are dividing angle. Got it? Here we are dividing angle. So half of this angle, that means half of this angle and half of this angle. Okay. So this angle is equal to this angle. This angle is equal to this angle. This angle is equal to this angle. This is called, and this point is called incenter. Okay, let's write I, X, Y. All right. See, medians, it is always divided into 2:1 ratio, right? If you remember, 2:1, 2:1. Remember? It will always divide in this type of ratio, 2:1. Here the ratio is different. Here the ratio is A is to A plus B. Now what is A and B? We'll talk about that later, not now. Okay. When we are solving, I'm just trying to give you. So how do you find X? Again, X1, Y1, X2, Y2, X3, Y3. How do you find X? Incenter is little difficult. Okay, I have to give you the ratio. Let's say this is dividing in the ratio A is to A plus B, some ratio like this. Okay. So from this point to this point is A, and from this point to this point See, from here to here, if it is a plus b, so from here to here, it is b a. This a and b are some numbers which will get clarified, which will be given. Okay. Something is wrong here. In center, I'm little confused, a little bit. Sorry, my mistake. So suppose, can you give me some time for in center? I will have to clarify it in center. In center, just leave it for now. So these midpoint. So if you have to find midpoint, that means here m is equal to 1, m is equal to n is equal to 1. If you have to find the midpoint, okay, midpoint of this line, that means m and n will be equal. In center, I'll explain you a little later. Write down the next locus of a point. Locus related to okay, equation of locus. Write down equation of the locus. How do you find a locus from a given relation? Let's write down, start from a question. So suppose there are 2 points given, 3 points, A, B, and a point. Okay. So it's given that there are 2 points. Also, it is given that find the locus of point P. There is some point P, X, Y, okay, which moves so that this point is moving such that moving on a track such that AB, AB not AP, PA is always perpendicular to PB. Okay, the point P is moving such that PA is always perpendicular to PB. Okay, that means what? Suppose this is AB, A and B, and there is a point P, okay, X, Y. It is moving such that AP, so this is 90 degree. It is moving such that this angle is 90 degree all the time. Okay, we don't know the coordinate of A, we don't know the coordinate of B. So what we, okay, no, coordinate of A is given minus A comma 0. B is also given A comma 0. That means it is on x-axis, right? That means this is on x-axis. So this is Y and this is your X. I hope online guys, you are able to hear me, and it is
Yes, sir.
A. And now what relation do we know? Do we know anything till now, whatever we have studied? We have only studied distance formula, right? So we will use distance formula. See, if this angle is 90 degree, that means AB square will be equal to AP square plus BP square plus, now find out. Just write down AB. How do you find AB? Square root, AB square. Pythagoras theorem we have used, okay? So AB square will be A minus A, so A plus A square plus 0 square, so A plus A square root of this. No, whole square, right? We just need to find square. This will be equal to, isn't it? Is that correct? Yeah, this is correct. AP, find out AP. AP will be X minus A, X plus A whole square plus Y minus 0, that means Y square, isn't it? Plus BP square. How do you find BP square? BP will be X minus A square plus Y square, right? Is that it or not? So this is 4A square will be equal to X square plus A square plus 2AX plus Y square plus X square plus A square minus 2AX plus Y square. This and this will get cancelled, right? X square will be, so this will be 4A square will be this, and this you'll add 2x square, right? plus 2a square, this and this we are adding, plus 2y square, right? So here also a square, so this will become 2x square plus 2y square is equal to 2a square. I'm just taking this to this side. Okay, this side. Now that means you are getting x square plus y square is equal to a square. This is also equation of circle, right? That means the point P is moving on a circle. Equation of a circle. See, we have studied this equation twice, once in trigonometry and once in complex number. Okay, so that's how we know equation of circle. Anyway, we are going to do that chapter, right? Therefore, you can write point P is moving on a circle. Okay, you don't have to write it if you don't know. That means point P is moving using this equation. That's it. Okay. See what? So what was why we did this? This is just to show you with the given information how do we find the locus of point P. Okay. So this we can do using means there are different methods that we can solve it. Now write down straight lines. Let's enter straight lines. See, in straight line, we will always use the coordinate system, right? We are using the coordinate system to understand straight line. We are always doing that. So suppose this is x and y. What happened? Okay. Now let's say this as a reference we are using y and this as x. All right. So till now, what do we know about straight line? It's any line that you can draw, right? Like this, or like this, or like this, any line, all are straight line. Okay. Now you will observe one thing, that all lines will somehow intersect this axis, right? Always they will intersect this x-axis somewhere. It will intersect it somewhere around here, right? So it will intersect somewhere around here. This angle alpha, let's say beta. Okay, let's say this one is theta. Okay, so the slope, how do we calculate the slope? Okay, so tan theta, tan of angle theta will give slope of this line AB, let's say L, is equal to slope of line L. Okay, if this is line M, so tan alpha is the slope of line M. Similarly, if it is N, so tan beta will give you the slope of line N. Okay, understood? Got it? It's not that tough, isn't it? Now let's understand about slope. We are studying slope of a line, right? Slope. We are trying to understand slope. First, understand this is theta. This angle is called angle of inclination. Okay, angle of inclination it is called. Now theta is, if theta is greater than equal to 0 and lesser than what? Lesser than what? 90. So tan theta is what? Which this will give you tan theta what? Positive or negative? Tan theta is positive. That means slope is positive, isn't it? This is your slope. Positive slope, no? Okay. What if theta is the same thing that we have done? Is greater than 90, but lesser than equal to 180. See, we are not talking about 90 because tan 90 is what? Infinity. Okay. So what is happening here? Tan theta is positive or negative? Negative, right? So slope is negative. Understood this part? Hopefully this is clear. So let's say if this is A, B, let's draw the example of A. That means just the first coordinate, right? Quadrant. So these all are example, right? So theta is always lesser than 90. See, theta is always lesser than 90. For this one, how we can draw? Either it is like this, that means theta is what? This is your theta, or it can be like this. It can be like this, right? So these all are negative angles. Not negative angles. This tan theta is slope, negative slope. Okay, so these are all negative slope. Positive slope. Okay, negative slope, positive slope. See, how do you measure theta? How to measure theta? You don't have, first, let's say you have a line. Okay, you have a line, something like this. Okay, first what you will do, you will always draw x-axis. X-axis is the horizontal axis, right? So horizontal axis you have already drawn. Now you draw this angle here. Now, how do you know it is greater than 90 degree? Because you can draw a perpendicular exactly at this point of intersection. Okay, I didn't know this property of my tablet or office. Okay, so this is x, y. Always first the line is given. You draw the horizontal axis, draw the angle, and see it is greater than 90 degree, right? See, theta is greater than 90 degree. Slope is negative. Negative slope. Okay, so anything in this direction is negative slope. Anything in this direction is positive slope. Positive slope. Okay, got it? Okay, hopefully this point is clear to you all. So what about if theta is equal to 0 degree? If theta is equal to 0 degree, what do you mean by that? You have a line such that theta is equal to 0, x, y. So when is theta 0? It's a straight line parallel to x-axis, right? Straight line parallel to x-axis. This is your theta is equal to 0, right now? Slope is 0. Okay, that is tan theta is equal to 0. Tan 0 degree. Right? What if theta is 90 degree? If theta is 90 degree, what happens? Slope is, we call it infinite slope. That means a line parallel to y-axis. Okay? A line parallel to y-axis. So these are all theta 90 degree. Okay? Infinite slope. Also, in this chapter, we are going to represent slope. The slope, which is tan theta, by a symbol m. Okay, we are going to represent tan theta by m. All right. Now, question. Anyway, we are going to study main state. See, if you understand one equation of straight line, I think everything is done. If you understand it properly, not just partial understanding. Okay, this is the equation, I just memorize it. No, you have to understand it. So let's find out. And we are heading to that process. What is the slope of line? Find the slope. Find slope. If A, theta is equal to 90 degree, B, theta is equal to 60 degree, C, theta is equal to 120 degree. Find M1. M1 will be how much? Tan theta 1. For A, we are doing the calculation. How much was that? Tan 90 is how much? Not defined. M2. 1060 is how much? Eh? √3. Okay. C. M3 is how much? 10/120 degree. See, in trigonometry, I wanted to tell you guys how to find angles. For different angles, what I have felt that you guys are having trouble finding, how to find the value of 10/120 degree or 145 degree like that. How do you do that? So, I'll try to manage a class, please, but you have to come to that extra class. Okay, then only you'll be able to. I have made a really, I think it's a good note that will help you. How much will be that? 10/120. 10/120 is how much? How come it is? This is 10/180 minus how much? 60, right? So that is 10 minus 1060 because it is inside. I have seen you have made a lot of mistakes in trigonometry. I've checked your paper earlier. So minus √3. You have, nobody has taken Shreya also. Nobody of you have taken care of which quadrant it is given the angle. No one. So you have to understand that part. Okay, so what I'll do, I'll just, okay, one more last point what I want to give you is, suppose there is a line. Okay, there is a line like this and you are given 2 points. Okay, you know 2 points, let's say P, x1, y1 and Q, x2, y2. How do you find the slope? Slope is M is equal to slope of PQ. Slope of PQ is M, which is tan some angle theta we don't know about. This is given by y2 minus y1 upon x2 minus x1, or you can also write y1 minus y2 upon x1 minus x2. Whatever you feel comfort. So from here you can find the value of theta also. Suppose you are asked to find the value of theta. See, one equation of straight line that I wanted to write is y is equal to mx plus c. This equation will always define any straight line. You just need to find the value of c and you need to find the value of m. That's it. So we are going to study more about this in tomorrow's class. Okay. So this, about this we are going to study tomorrow. All right. So that I'll end the class. Thanks. Thank you very much.
Thanks, sir.
Hopefully, I think tomorrow the classes will be online. So if you want, you can join. Okay, I have to end the class also, right?